Systems Homework 2.7. So, these first ones, 3 points are given. Each point is a solution to at least one of the equations. Find the point that satisfies both equations. This is the solution to the system. Okay? So we're going to check these points and see which ones work in both. So to do that, remember we're dealing with a coordinate here, so it's got an x value and a y value. So like -2, 5. And we're plugging them into the x and the y value of our equation. That's how we check it. So we take that first equation. Instead of y, we put a 5 in there. Then 2 times, instead of x, we put a -2. And then we simplify. 2 times -2 is -4. Minus 3 is -7. That does not equal 5. So I know that's not an answer to both. And we try b. So the y value in, then 2 times the x value. 2 times 2 is 4, minus 3 is 1. Does 1 equal 1? Yeah. So b works in the first one. Does it work in the second one? 1 for y, negative, and then the x value of 2, plus 3. -2 plus 3 will give us +1. That one checks off as well. So there's our answer. Okay. Now if we're dealing with the other next problem, we do the same exact steps. Okay. Same exact. We're just taking those points, plugging them into the equation, and then seeing which ones work and which ones don't. The ones that work, those are our answers. So let's try A. So 0 for y, 3 times -1 for x, plus 3. That becomes -3 plus +3 is 0. 0 does equal 0, so it works for the first. So let's try it for the second. 0 for y, -1 for x, plus 3. Two negatives make a positive. 1 plus 3 gives us 4. 0 does not equal 4, so A is out. Well, let's try B. So x is 6, -3 is y. So -3 equals 3 times 6 plus 3. 3 times 6 is 18, plus 3 is definitely not -3. Okay, so that one's already out because it didn't work in the first. So now C is probably the answer, but let's double check. 3 for y, 0 for x. That cancels. Yep, 3 does equal 3. Works in the first. Try the second. 3 for y, 0 for x. Yep, -0 is still 0. 0 plus 3 is 3, so it works in the second. So C was our answer. Okay, so we're just taking each equation, plugging in the points. And this has to do with just those systems, right? Because what we're looking for in the systems is we're looking for a point that satisfies both equations, just like this. Only we're not given the points. We either have to graph them or use that new method, substitution. Okay, so number 4. So we've got a standard form equation. Let's deal with that one first. So 1 for x, 6 for y. Does that equal -5? Nope. So I know A is not it. Try B. -3 for x, -2 for y. Does it equal -5? Yep, add them together. It works. B works for that second one. What about C? -3 for x plus +2 for y. Nope. So I know it's not C, so our answer is going to be B, but let's just double check in our second equation. Or I guess our first equation, because we skipped to the second. -2 for y, 2 times -3 for x. 2 times -3 is -6 plus +4 is -2. So yep, that one worked. Okay, now number 3, we've got y equals 2. Right off the bat, that one should tell you that your answer is not going to be B. Because my y value has to equal 2. So that worked because they're both 2, but B does not. Okay? So I know A and C will both work in this one. So now I just need to check my second answer. So 2 for y, -4 times 7 for x, minus 6. -4 times 7 It's negative 28 minus 6 would be negative 34. Definitely not equal to 2. So let's try it in our second one now. 2 for y, negative 4 times negative 2 for x, minus 6. That would be a positive 8. Minus 6 would keep us a positive 2. So yes, it works. So there's our answers on those first couple. Moving along. Okay, now we're dealing with substitution. Remember, the whole point of substitution is to substitute one variable in for something else that you can then solve with. So if we look at 5, and we're looking for our point, our answer should still be in that point. Okay? So if we look at 5, I've got y equals 3. So I know right now that my y value of my point is going to be 3, because that's the only thing y could equal. So then, because 3 and y are the same thing, I'm going to replace this y with 3. Because doing that will allow me to solve for x. So I get 3 equals 5x plus 18. So I subtract 18 from both sides. 3 minus 18 is negative 15 equals 5x. Divide by 5, and we get negative 3 equals x. So my point that satisfies both of these, just like over here, only this time we're looking for it, is negative 3, 3. Now, if I look at 6, it's a little different. I don't have one of these that's just a number over here, right? So I don't know what my answer is yet. So, what I look for is a variable by itself. I've got 2 of them, but I just look for this one. Say, okay, I can take this y value. It's equal to that whole thing. So I can substitute that whole thing in for y. So instead of y, I've got 3x minus 7 equals 8x minus 7. Okay, so we can get rid of those parentheses because there's nothing to multiply by. So I'd subtract a 3x from both sides. Okay, the x is on the same side. Negative 7 equals 5x. 8 minus 3 would give us 5. Minus 7, so I'm going to add 7 to both sides. Negative 7 plus 7 is 0. 0 equals 5x. So we divide by 5. 0 divided by 5 is still 0. So x equals 0. So I've got my x point is 0. Well, now I know what x is, so now I can go back to either of my equations up here and say, well, if I know what x is 0, what is y going to be? Well, 8 times 0 is 0. 0 minus 7 is negative 7. So that's what y is, negative 7. If I want to check the other one, 3 times 0 is 0. 0 minus 7 is negative 7. So there's my answer, 0, negative 7. Alright, and so that's all we do. So number 7, same idea. Y equals negative 3x minus 16. Y also equals negative 2x minus 11. So I can even take that one and replace it with the other y. Doesn't matter which one I replace as long as they're equal to each other. So instead of y, I've got negative 2x minus 11 equals negative 3x minus 16. Now, I could graph both of these and look to where they intersect. We can always do that as well. So let's add the 3x to both sides. Those would cancel. Negative 2 plus 3 would give me a positive 1x. Minus 11 equals negative 16. Add 11 to both sides. We get x equals negative 5. Now I know what x is, so I take my equation, plug in the negative 5 for x. 3 times negative 5 is positive 15, minus 16 is a negative 1. So my answer is negative 5, negative 1. So if I were to graph those two equations at negative 5, negative 1, that is where they would intersect. Okay, that's where they would intersect. That's what that means, right? Still that same concept. Alright, there's number 7. Let's take a look at number 8. So now this one isn't solved for a variable, but this one is. So I still want to deal with this. I want to say, okay, I know what x plus 4 is the same thing as y. So instead of this 6 times y, I'm going to go 3x plus 6 times y equals 24. But instead of that y variable there, I'm saying, hey, this other equation told me y is x plus 4. So I'm just going to put x plus 4 in there. Then we multiply, and I get 3x plus 6 times x is 6x plus 6 times 4 is 24 equals 24. Subtract 24 from both sides. We add those two together. 3 plus 6 would give us 9x equals 0 divided by 9. X is equal to 0. Simple enough, right? Then I'm going to take that equation and say, okay, if x is 0, what is y going to be? 0 plus 4 is 4, so y equals 4. So my answer is 0, 4. That's where they intersect. That's where they're the same. Alright, next one, same idea. This 5x minus 14 is the same thing as y, so let's replace that y with 5x minus 14. So we get negative 8x. Negative 7 times 5 is negative 35x. Negative 7 times negative 14 is positive 8 to 98 equals 12. Combine those two. Negative 8 minus 35, it's like we're adding them together. So it's going to be a negative 43x. Then subtract 98 equals, well, 98 minus 12 would be 86. So negative 86, because it's positive and that's negative. Divide by negative 43. And we get x equals a positive 2. Alright, now we know half our answer. So I go to this and I go y equals 5 times, now I know x is positive 2. So I substitute one more time. So this is why it's called substitution, because we're substituting this piece in for the variable and then this variable with the number. That's 10. 10 minus 14 is negative 4, so y equals negative 4. So our answer to negative 4. If we graphed it, that's where they would intersect. Okay, number 10. Same exact process. We're going to take that and plug it in for y. So negative 4x plus 4 times, instead of y, negative 5x minus 22 equals negative 16. The reason we can do that, because this equation tells us these are equal. They're the same thing. Y is that negative 5x minus 22. Okay, so we get negative 4x plus 4 times negative 5, negative 20x. 4 times negative 22, negative 88 equals negative 16. Add the 88 to both sides. Oops. So 88 minus 16 would be 272. Okay. Then negative 4 and negative 20 would give us negative 24x. Divided by negative 24. Positive divided by negative is a negative. 72 divided by 24 is negative 3. Then we take that original equation and we say we now know that x is negative 3. And it doesn't matter which equation you plug the x back into. Positive 15 minus 22. So y equals negative 7. So our answer, negative 3, negative 7. That's where they intersect. So that's how we use substitution. Okay, some more problems. Just keep working through it. Okay, so now none of these ones are solved for x. So here's kind of an extra step you sometimes have to do. I want to get this x by itself. So I'm going to, well, there's actually two ways you could do this one. I'll show you both ways. The first way would be to say, hey, this has got a negative 3x. So if I can set something equal to that negative 3x by subtracting this negative x, I have negative 3y equals negative x minus 5. Well, I've just been told that negative 3y is equal to negative x minus 5. So I could go 4x and then substitute that negative 3y with negative x minus 5 equals negative 11. Then because I don't have that multiplication, I can simplify this way. 4x minus x is 3x. Add 5, and we get negative 6 divided by 3, and x equals negative 2. Okay, that's one way we could have done it. The other way would have been to solve for x. We could have added 3y. We would have got x equals 3y minus 5. Okay, same thing. Then we take this and we replace the x, so it would be 4 times 3y minus 5 minus 3y equals 11. And we get 12y minus 20 minus 3y equals 11. Add 20, and then 12 minus 3 would give us, oh, that was negative 11. Okay, so 12 minus 3 would give us 9y. Negative 11 plus 20 would give us 9. Divide by 9, and you'd get y equals 1. Okay, now they were solving first for different variables. So if, to double check that, you just plug negative 2 in for x. Up here, if we plugged it in to that original, we had negative 3y. No, hold on. Okay, so it doesn't matter which variable you solve for first, it's still going to work. Okay, so that first way we did it, we had negative 3y was equal to negative x minus 5. So plug in a negative 2 for that negative x. That'd be positive 2. So 2 minus 5 is negative 3. Negative 3y equals negative 3. Divide by negative 3. And we get y equals 1. Just like we did down here, right? So our answer is negative 2, 1. Now, if you went the other route, where you solved for x, okay, when you plugged in 1 for y here, 3 times 1 minus 5 would be 3 minus 5 would be negative 2, just like we did over here. Okay, so you can solve for two different ways here on these guys. Alright, so 12, I want to get this x by itself, so I'm going to add 2y to both sides. So I end up with x equals 8 plus 2y. So now I can replace that x in this one with 8 plus 2y. Remember, the whole point is to get it so you only have one type of variable, which then when you simplify, you can actually solve it. That's the whole point here, is to be able to solve for the one variable. And once we've got one variable, it's easy to figure out the other variable. And so we get our answer. Once we've got the two variables, we've got our point, we write down our answer, and we're good to go. Alright. Okay. So once again, on 13, I have two options. I can try to solve for just y, which is typically we want the simplest variable. Or I can say, hey, 3x and 3x. Well, if I subtract this y here, I get 3x equals 8 minus y. I can substitute this whole 3x out and have that 8 minus y minus 3y equals 0. So it would be 8 minus 4y equals 0. Subtract 8. Negative 4y equals negative 8. Divided by negative 4. And y would equal positive 2. Plug in 2 here. 8 minus 2 would give us 6. Divide by 3. And we get x equals 2. So the point 2, 2 is where those two equations intersect. Okay, there's other ways. There's multiple ways we can do each one of these problems. It just depends on how you want to do it. And as always, if you'd rather just try to graph these, by all means you can graph. Okay, now in number 14, we're not going to have as easy of a fix. So let's just get one variable by itself. I'm just going to pick this one. Doesn't really matter which one. Same process is going to work for either one. So 4x equals 8y minus 12. But I don't have a 4x up here, so I just need to get to x. So I divide everything by 4. We get x equals 2y minus 3. Now I can substitute in for x in our other equation, and what I put there in its place is 2y minus 3. Now I've just got y's. Now I can simplify. Negative 12y plus 18, because we distribute, minus 6y equals 18. Subtract 18 to both sides, we get 0. Negative 12 minus 6, negative 18y, divide by negative 18, and we should know that y has to be 0. Okay, y value of 0, plug it back into this equation, we find our x value of negative 3. So the point where they intersect, negative 3, 0 on the x-axis. Alright, okay, now this last is more or less review, dealing with fractions. Now remember, with fractions, the easiest is the multiply. Because multiplying, you just multiply the top, across the top and across the bottom. So 3 times 2 is 6, 4 times 9 is 36, then we reduce. We can divide those both by 6, so we end up with 1/6. 20, 4 times 7 is 28, 7 times 10, 70. We can actually divide both of these by 4, or actually by 7, and we end up with 4 over 10, which we can divide again by 2, and we get 2/5. Which, notice, 7 on top, 7 on bottom, those could have canceled out, and we could have just said 4 over 10, which reduced to 2/5. Okay, 21, 5 times 2 is, okay, there's multiple ways we can do these, but most of you probably like this way. 5 times 2 is 10, 4 times 9 is 36. I can divide those both by 2, which would give me 5 over 18, which we can't reduce that further. The other way would say, okay, isn't 4 really like 2 times 2? So that 2 on the bottom, one of them, and one of the 2's on the top cancel out, so that's like 1. So then 2 times 9 is 18, 5 times 1 is 5. Okay, on 22, 3 times 8 is 24, 7 times 21, 147. Okay, can we reduce that? And the answer is yes. That's when it's helpful to sometimes simplify before you solve. Okay, so if we look at this and I say 3 over 7 times 8 over 21. Well, isn't 21 3 times 7? So can't I get rid of this 3 and this 3? And then I'm left with 8 over 49, which can't reduce, which is what the other one would have reduced down to. Okay? So there's multiplication. Now, dealing with addition, that's the troublesome one, because we have to have common denominators, right? So, to get these common, 4 can become 8 if I multiply by 2. If you do to one side of the fraction, or to the bottom of the fraction, you always have to do the same to the top. So I really have 6 over 8 plus 1 over 8, which now I just add the tops, so we end up with 7 over 8. Okay, same with 16. I got 3/5 plus 7/10. Well, I think, well, I can double 5, so I have to double 3. So I get 6/10 plus 7/10, which equals 13/10, which that's where we want to leave it. Sometimes they told you, well, 10 goes into 13 one time, and we have 3 left over. But this said improper leave, not to make those other ones. Okay, let's clear some space. Alright, so 2/3 plus 1/4. Now we can't make one or the other, right? So you've got to think, okay, where do they meet? Well, if we count by 3's, we go 3, 6, 9, 12, 15, 18, 21, 24. If we count by 4's, 4, 8, 12, 16, 20, 24. You may say, well, hey, they can both become 24. But if we search, we also notice they can both become 12. Take the smaller number. So 3 becomes 12 by times and by 4. 4 becomes 12 by times and by 3. So I get 8 twelfths plus 3 twelfths, which gives us 11 twelfths. Is our answer. Okay, 18. Kind of the same idea. To get 7 to be 21, we times by 3. So I have 12 21s plus 8 21s, which equals 20 21s. And there we go.